All right, now we're going to look at finding area enclosed by. Enclosed means completely surrounded by two functions when they intersect at most 2 times. All right, so they're going to intersect twice. That's sort of the first step. We want to find out where our functions cross, where they intersect, which that means we want to find when are my functions the same value, right? That's what it means to intersect. All right, there's an algebraic way to do this, and there's a graphing way to do it. And I'm going to go over both. All right, I'll probably focus a little more on the graphing method because that's the method students tend to use, but I will do one example where I'll solve it by hand. All right, so that's the first step. Find where my two functions intersect. All right, so find where my two functions are equal. Where they intersect is where they're equal. All right, so suppose these particular functions are equal at a and b. Second step is figure out which is bigger. So that's where where they intersect, because again, basically what the picture is, it'd be something like this. All right, I have my function f of x, I'd have my function g of x. These would be where they intersect, so that would be a, that would be b. This would be the area we're looking for. All right, and so the next step is to figure out, well, which is the bigger function, which is the smaller function. So which function, this would be the bigger one above, this would be the smaller below, right? And it's completely surrounded by. And so that's the second step. Over that distance a to b, where the area is the f of x function the bigger one, or is the g of x function the bigger one? All right, and again, there's a by hand method and there's the calculator method, and I'll go over both ways. But it's important. It's important we figure out which function is bigger because it matters how we subtract, right? Which is the next step. Once I've established f of x is bigger than g of x over the interval a to b, then that area is that integration where I take the bigger function minus the little function, right? Remember, it reorients the area between a and b, right? And then it'll find the area, right, using the fundamental theorem of calculus, or vice versa. If g is the bigger function, again, then we use the other subtraction. Again, always take the bigger function minus the little function. If you don't, you'll get a negative value, and area should always come out positive. All right, so again, if you've done a negative value, it means you've subtracted wrong. All right, and so you need to flip your subtraction. Area should always come out positive. All right, we'll look at some examples. So like I said, I'm going to do the first couple of examples all on the calculator. So hopefully you have your graphing calculator out, and I'm going to pop mine up here and work it through with you. All right, find the area bounded by the given curves using a definite integral. Make sure you show and give me the definite integral, and then you can solve it on your calculator. All right, so the two functions that we're looking at are f of x, which is 2x minus x squared, and g of x, which is equal to x squared. And so the first thing we have to do is figure out when f of x is equal to g of x. And you could set them equal to each other and solve, and that's fun. That's the by hand method. And our last example, I will do that. I will do one example where I'll do it by hand. The first two examples, though, I'm going to do graphically because most students will do this graphically. And it will show you the relationship between the area, between the functions, and the area under the function where we subtract correctly. Alright, so step 2, after I find that, is figure out, well, which is bigger. And then we set up the integral once we found those two things. And like I said, I'm going to do this all graphically. Alright, so I'm going to pop up my graphing calculator. So I've got my TI-84 here. I've already plugged in the first two functions. Alright, remember you go to y equals, I've got my first function, x squared minus, 2x minus x squared. And my second function, which is x squared. Alright, excuse me. Alright, go to graph. Alright, now it's hard to see where the area bounded is, so I'm actually going to hit zoom and in. So I'm going to zoom in, and I'm going to zoom in, around the origin. We'll just hit enter there. Alright, and so there's my two functions. Alright, so there's my graph, and there's the area we're looking for. So if I go back and draw this, alright, and so the area we're looking for is this area here, right? And so I need to figure out what that x value is and what that x value is, right? Where are they equal? Where do they intersect, right? That's step one. All right, so that's step one where I have to figure that out. Well, I'm going to do this graphically. Remember, our calculator knows how to do this. We go to second, trace, hit 5. All right, and then it'll ask us some questions, first curve, second curve, and guess. And just get your values as close as you can to where they intersect. And then I usually just hit my button 3 times as long as it's a pretty good spot, and it is. All right, and so they intersect at the point x equals 1. All right, now I've got to find this other spot where they intersect. So again, second trace, 5, first curve, second curve, and guess. So now I move my cursor to the other point. Oops, too far. Hit enter again as long as it's close enough. Second curve, I don't look like I have to move it. And my guess looks pretty good. All right, 0, 0. All right, so now I know where they intersect. All right, add x equals 1 and x equals 0. And so there's my boundary. I'm going to integrate. My area is over a to b, which is 0 to 1. All right, then the second thing is to figure out which function's bigger. Well, the function x squared would be my g of x. Well, that's the parabola that's opening up, so this is the g of x function. And then the f of x would be the one that's opening down. That's f of x. So f of x is above g of x between 0 and 1. Right? That function's my bigger function value. So f of x is greater than g of x over the area we're looking for. And so now we set up the definite integral. So my area is equal to integrating my two functions between 0 and 1, taking the bigger function first, so this is the bigger function, 2x minus x squared, and subtracting the little function, which is x squared, with respect to x, and I will simplify that. My area is integrating 0 to 1, 2x, and then my negative x squared minus my x squared will give me a negative 2x squared. Right, so remember, this is a new function, right? I've taken my f of x, right? This is my f of x, and subtracted my g of x. And we talked about this before. This gives me a new function that I can find the area of using the fundamental theorem of calculus. And so when I go graph that in and solve this graphically, so now I'm going to go in and regraph this new function where I've taken f of x minus g of x. And so I'm going to go back to my calculator, hit y equal to, clear out what I've got there, clear out what I've got there. Now I'm going to type in my new function, which is 2x minus 2x squared. Alright, and hit graph. Alright, and it graphs the new function. There's my new function. Alright, and I'm going to find the area from 0 to 2. Alright, so I'm going to hit second trace. Remember, we're integrating between 0 to 2. So 7 is my integral. Right? 7 is what I want to pick. My lower limit 0. Enter. My upper limit's 1. Enter. And there's my area, 0.333 repeating, which is 1/3. And notice that it's the area of this function between 0 and 1, and it's all above the x-axis. It's positive because that's the part of the function that I'm looking at, and that's the part of the function where f of x was bigger than g of x. Alright, so if I go back and graph, when I found the area of this, it was, again, we drew a new function which we could solve using the fundamental theorem of calculus, which that's what this area represents. This is the new function, f minus g, which was 2x minus x squared. That area came out to be 1/3, and so the answer is 1/3. The area between those two functions is exactly 1/3. Right, the area enclosed by my two functions is exactly 1/3. Alright, my next example, which again I'm going to solve using the calculator. Alright, so I've got my, this time it's two parabolas. Alright, so I'm going to type them into the calculator. Alright, so I'm going to clear this so I have a clear looking picture. So again, going here, clear that out. Type in my first function, which was x squared. It's not times. X squared plus 8x minus 10. Alright, and then my second function was negative x squared plus 10x plus 14. Alright, and I'm probably going to go back to a standard window. I may have to adjust my window. Sometimes the hardest part about these is find the window. Alright, but I'm going to go back to a standard window, so I'm going to hit zoom standard. Alright, so I am going to have to make my window a little bigger. Alright, so it looks like it goes well above and below here, and doesn't go very far out. So I'm going to adjust my window. Alright, I might just go to -5. Oops. -5. 5. And I might go up 20 and down 20. We'll start there. So 29. We'll see if that gives me a good enough window. I still might have to adjust my window. Yep, still have to go up bigger. Alright, so I'm going to go 30. I'll try 30. Alright, so I can see the lower one there, but I still have to go up bigger on the higher value there. Looks like I still need to go quite a bit bigger. So my maximum, I'm going to try 50. Alright, now I can finally see my area. Alright, so there's the area I want to find. So this is going to be a fairly large area, so I had to make my window quite big. Alright, but the first step, remember, I want to find where my two functions are equal. Alright, so second trace intersect. Alright, first curve, second curve, and guess. Alright, so at 4, alright, now looking at the other one. Alright, -3. Alright, so -3 and +4 are in there. So if I go back, I write that out. Alright, so first thing we find is when is f of x equal to g of x? Well, we found that f of x is equal to g of x. They intersect at -3 and +4. And so when we find the area, we're going to integrate the area over 3 to 4. Alright, the second thing is to figure out, well, which function's bigger. Alright, so which is the bigger function? Which again I can do graphically. If I go look at the graph of my function, alright, there's the parabola that's opening down, there's the parabola that's opening up. Alright, if we go kind of draw that shade off on my piece of paper, right, I've got a function. Alright, they're intersecting at those moments. Parabola shape. that was the area we want to find between 4 and negative 3. Right? And the way we can tell which function is bigger is you go back and regraph it if you want to. But remember, when I've got a negative on the squared term, that's the one that's opening down. So the function that's opening down is g of x. And the function that's opening up, well, the positive on the x squared is opening up. And so that's f of x. So this time, g of x is bigger than f of x over my interval. Alright, so g of x is the bigger function. Alright, so I'm going to take g of x and subtract f of x. And when we want to find the area, I'm going to integrate from negative 3 to 4. I'm going to take my g of x and subtract away my f of x. Alright, so my area is negative 3 to 4. G of x was the negative x squared plus 10x plus 14 minus f of x, which is x squared, plus 8x minus 10. Alright, simplify it. Always write your integral in simplified form. And so we're subtracting. So negative x squared minus x squared, well, that's going to give me a negative 2x squared. A 10x minus the 8x will give me a positive 2x. And a 14 minus a negative 10 is really 14 plus 10, so 24. And if you need to, distribute the negative and simplify that way. But since we were subtracting all the parts, I just went ahead and subtracted as we moved along. Alright, so there is my new function, which represents f or g of x minus f of x. That's going to give me an equivalent area where I can solve using the fundamental theorem of calculus. Alright, and so when I regraph this function, it'll give me the same area as the in-between, but I can solve it by using the fundamental theorem of calculus. Alright? And so we want to see this, the definite integral, and then we want to solve it. And again, I'm going to solve it graphically, and it should give me a parabola function. So I'm going to regraph the new function. So I'm going to get rid of these. Alright, and regraph my new function, which was a representation of my subtraction of the bigger function minus the littler function. Alright, give me a second because it does take just a little while to type this in on the computer. I shouldn't have to adjust the window, I don't believe. I think it will graph. There it is. Alright, so that's my new graph, and if you'll notice, it's hitting the axes at negative 3 and hitting the axes at positive 4. The area above it is the area that I want, right? And so we go find it. Second trace, 7. My minimum is a negative 3. And my maximum was a positive 4. Right? And it'll shade it in and find it. So 114 and a third, right? 114.3 repeating is the area. Right? So the area is 114.33 repeating. All right, which again, we found it by regraphing that new function from negative 3 to 4, found this area, right? That's how we found the area, and that area is exactly the same as this area, all right? But we had to adjust it in order to use our fundamental theorem of calculus. All right, and so there is the definite integral that finds the area between, and there's the exact area. And so those are the two things that I want to see when I ask you these type of questions. I want to see your definite integral where you've set it up and subtracted correctly. Right, and then I want your final area, and it should always be positive. If it comes out negative, it means you've done your integration wrong. You subtracted incorrectly. Alright, so again, this number should always come out positive. The last example. Alright, give the definite integral that solves the exact area. Bounded my curves g of f and f of x. Show me the simplified integral with correct notation. Give the general antiderivative with correct notation. Alright, so this one I'm going to solve by hand. Alright, I'm going to solve the entire thing by hand. Alright, so most of the time, again, you can solve it either way unless you're asked to solve it by hand. You should be able to do it either way. You should be able to solve it with the calculator, or you should be able to solve it by hand. Alright, and so this is going to be the last example, which I'm going to go through and solve the entire thing by hand. Now, you could check my answer graphically, but note, you should be able to do it both ways, by hand or graphically. Alright, So the first thing we have to do is figure out, well, when does f of x equal g of x? Alright, so I've solved this algebraically. I take my f of x, which is negative 5 plus 28, set it equal to my g of x, and solve. Alright, first step, it's a quadratic, so I've got to set it equal to 0. Alright, and I'm actually going to move g of x over because I don't like negatives on my square term, and I'm going to do it all in one step. If you need to take more than one step, take more than one step, but I'm going to move the whole thing over, means I'm going to add my x squared term, I'm going to subtract my 10x, and I'm going to add 8. Alright, which means all of this will zero away, and on this side I'm left with x squared minus 15x minus 36. Alright, it does factor, but you could use the quadratic formula if you want to. Alright, but this one does factor. Factors that multiply, it should be a positive 36, right? 28 plus 8, positive 36. Alright, factors, when I multiply them I get a positive 36. When I add them I get a negative 15. Well, negative 3 and negative 12, right? Negative 3 times negative 12 will give me 36. Negative 3 plus 12 will give me my negative 15. And so where my function intersects, if you graphed it, alright, you would find that the two functions cross at 3 and 12. Alright, and so that would be where I'm finding my area. I'm finding my area from 3 to 12. Alright, so that's the first step. Alright, finding my area. The second step, step 2, which is bigger? Alright, well, without graphing it, and this time I have a line and a parabola. My parabola is opening down, my line is somewhere on it. Alright, well, we can test the value to see which is bigger. Alright, our area is between 3 to 12, and one of my functions, because again, they're intersecting at 3, intersecting at 12, so between 3 and 12, one of the functions should be bigger. Alright, so I pick a test point. X equals, 5 is in between 3 and 12, right? It's in my interval. And so if I find f of 5 and I find g of 5 and I figure out, well, which one's bigger? And so I'm literally plugging 5 into my function f of x, and I'm taking 5 and plugging it into my function g of x. And so I'm going to take 5 times negative 5 plus 28. So that's going to come out so I get negative 25 plus 28, which is 3. So this is going to come out 3. And then when I plug 5 into my g of x function, alright, I'm going to plug it in here. And so I'm going to get 25, negative 25 plus negative 8, which is going to give me negative 33 plus 50, so that comes out positive 17. Alright, and so that means g of x is bigger, because it's 17 at 5, than f of x. Alright, my g of x function is the bigger function. Alright, area is from 3 to 2. I know that the g of x is bigger than f of x, and so I'm ready to set up my problem. So step 3, I'm going to integrate from 3 to 12. I'm going to take g of x and subtract away f of x in order to find my area. Alright, so setting up my integral and simplifying. So g of x was the negative x squared plus 10x minus 8. F of x was negative 5x. And remember, I'm subtracting everything, and so I'm just going to go ahead and write out my subtraction. So I'm going to subtract it. Negative x squared minus, well, there's nothing to subtract it from, so it's just negative x squared. 10x minus a negative 5x, so 10x minus a negative 5x is really 10x plus 5x, so I get 15x. Negative 8 minus 28 is going to come out negative 36. Alright, and there is, again, what I want to see. The definite integral simplified correctly, where you've subtracted correctly, and that will give me my area. And then you find the area, and like I said, I'm going to do this by hand, because I asked you to do it by hand. And so I'm going to integrate. So first thing I find is my general antiderivative, which is negative x cubed divided by 3. 15x squared divided by 2, negative 36x. Still haven't taken care of my 3 and my 12 yet, so I write them down here to remind myself I've just taken care of the antiderivative part, the integral part. Haven't taken care of the plus and minus part yet. And so again, I'm going to plug 12 in and subtract away plugging 3 in, and you show those values when we're solving it by hand. Alright, so again, I'm plugging 12